Now let us see turning moment diagram and flywheel. So this topic comes in the subject mechanics of machines or dynamics of machines in mechanical engineering degree. Right? So here it comes in mechanics of machines. So it is there in Anna University syllabus, it is there in IIT syllabus or any mechanical engineering syllabus. And this topic is also common for aeronautical engineering students, for automobile engineering students and industrial engineering students. Right. Now let us see this turning moment diagram and flywheel. So here, what is the purpose of flywheel? The flywheel is a device which absorbs energy when there is excess of energy, and it gives out its energy when there is a requirement of energy. Right. So here, in an engine, in an internal combustion engine, the flywheel plays a major role. So actually this is a 4-stroke internal combustion engine. This diagram is a torque turning moment versus crank angle diagram for a 4-stroke internal combustion engine. This consists of 4 strokes. These 4 strokes constitute one cycle in an internal combustion engine, both petrol and diesel engines. So here 4 strokes constitute one cycle. There are 2 revolutions of the crankshaft in 4 strokes. 2 revolutions. Therefore, every 2 revolutions constitute one cycle in a 4-stroke cycle engine. This is suction stroke, pi radian, right, 180 degrees. Compression stroke, another pi radian, another 180 degree. Power stroke, another pi radian, another 180 degree. Exhaust stroke, another pi radian, another 180. Therefore, 4 pi radians. So therefore, this is the crank angle turned by the crankshaft, 4 pi radians, and this is the turning moment on the crankshaft. This is turning moment is nothing but torque on the crankshaft. Right. So during suction stroke, the piston sucks in air fuel mixture in case of petrol engine and air in case of diesel engine. By the time the piston goes down from the top dead center to the bottom dead center, therefore there is off revolution completed, that is pi radians, by 180 degrees, off revolution completed. So this is suction stroke. At the end of suction stroke, the piston would have drawn air fuel mixture inside. So the piston is driven by the crankshaft, which in turn driven by the flywheel. The next stroke is the compression stroke. The piston goes from the bottom dead center to the top dead center and compresses the air fuel mixture, which is drawn inside during suction stroke already. Right? So here the air fuel mixture is compressed. Therefore, the piston goes up from the bottom dead center to the top dead center in the engine. The air fuel mixture is compressed. By the time another off revolution completed, the crank has turned another off revolution, therefore another pi radian. Then at the end of compression stroke, the air fuel mixture is ignited by the spark plug in case of petrol engine, or it is ignited by the high temperature and pressure in case of diesel engine. Right? So here after the mixture is ignited, it is burnt, it explodes inside the cylinder. The gases expand because of the energy released, chemical energy released. The gases, expanding gases, push the piston down with a great force. This is called the power stroke or working stroke or expansion stroke. So during expansion stroke, the piston is pushed down by the expanding gases. Therefore, the flywheel is driven. The crankshaft is driven by the expanding gases. The flywheel is driven by the energy. Therefore, during the power stroke, there is excess of energy. Therefore, the torque abruptly increases. During power stroke, the torque increases to the maximum value. It becomes maximum and then decreases. Because during power stroke, there is excess of energy. Energy increases, torque increases, speed of the flywheel increases to the maximum. and during power stroke the piston is pushed down and the piston comes down to the bottom dead center at the end of the power stroke. The exhaust, again after the power stroke, the exhaust stroke takes place and the exhaust gases are pushed away by the piston. Therefore, the piston is driven by the flywheel during exhaust stroke. Therefore, here the energy on the engine varies, right? There is excess of energy during power stroke. This energy is absorbed by the flywheel by means of kinetic energy. There is a requirement of energy during the other strokes. That is, during the other strokes, the piston is driven by the crankshaft, which in turn driven by the flywheel. Therefore, the flywheel has to give out its energy during suction stroke, compression stroke and exhaust stroke and drive the piston. During the expansion stroke, working stroke or power stroke, the piston is pushed down by the expanding gases and the flywheel absorbs energy. Therefore, the flywheel absorbs energy when there is an excess of energy and gives out its energy when there is a requirement of energy. Therefore, it reduces the fluctuation of energy on the engine. This is the purpose of the flywheel. Now, this is the actual torque versus crank angle diagram. So, 4 strokes are there. These 4 strokes constitute one cycle, that is 2 revolutions of the crankshaft. So, here during the suction stroke, it is less than atmosphere, therefore this is called zero pressure line. It is less than atmospheric pressure, therefore it is a negative area here. This is again during compression stroke also it is a negative area, right? The piston is driven by the flywheel, therefore it is a negative area. During expansion stroke, it is a positive area. Therefore, I idealize this diagram like this. This diagram is the actual turning moment crank angle diagram. For the sake of calculation, we idealize this diagram like this. Therefore, these areas, negative area, A1 is a negative area swept during suction stroke. Then A2 is a negative area during compression stroke. A3 is the positive area during power stroke, expansion stroke or working stroke. And A4 is a negative area during exhaust stroke. Therefore, work done per cycle is equal to net area. Work done per cycle is equal to A3 is the positive area A3 minus of A1 plus A2 plus A4. Therefore, this is the net work done per cycle in an internal combustion engine, right? So, N equal to speed in RPM. This is the mean speed of the flywheel. So, omega is equal to angular velocity, omega 2 pi n by 60, because one revolution is 2 pi radians, 360 degrees. Therefore, n revolution 2 pi n divided by 60, because it is in RPM, revolutions per minute, divided by 60, it becomes radians per second. This is the angular velocity. 2 pi n by 60 is the angular velocity, right? So, this is the turning moment crank angle diagram. This is the maximum fluctuation of energy, right? So, this is triangle is an isosceles. We have idealized this, right, into a proper figure here. It's an isosceles triangle. These two sides are equal, right? So, this is an isosceles. A, B, L is an isosceles triangle. Again, in a triangle you have delta E, maximum fluctuation of energy, right? So this is called the maximum. This triangle DEL shows the maximum fluctuation of energy. This is also an isosceles triangle. Therefore, these triangles, triangle LDE, triangle LAB are similar triangles. By using similar triangle properties, we can find out this, right, during calculation. Right. Therefore, here, this is the maximum torque Tmax, maximum turning moment on the flywheel, and this is the mean torque. Mean torque is the engine torque. This is the mean torque. Therefore, maximum torque minus mean torque, right, into this angle will give the maximum fluctuation of energy on the flywheel. The torque on the flywheel varies. It becomes maximum during power stroke or expansion stroke or working stroke. Right? And T mean is the mean torque on the engine. Therefore, we have to find the fluctuation of energy, right? The energy above the mean torque line. Right. So this is the turning moment versus crank angle diagram. Now let us see the next. So work done per cycle is equal to mean torque, T mean. This value is T mean. From here to here is mean torque. From here to here is the T max, maximum torque. Work done per cycle is equal to T mean into theta. This is equal to T mean torque into 4 pi for 4-stroke engine. Because for a 4-stroke engine, crank angle is 4 pi per cycle. Each cycle constitutes 4 pi radians. That is 2 revolutions of the crankshaft for 4-stroke. So the same work done per cycle. Here for 2-stroke engine, T mean into theta equal to 2 pi radians, that is 1 revolution. Right? In case of 2-stroke engine, every revolution constitutes 1 cycle. In case of 4-stroke engine, every 2 revolutions constitute 1 cycle. Therefore, in case of 2-stroke engine, it is theta equal to 2 pi. Every revolution constitutes 1 cycle. Every 2 revolution there is 1 power stroke here, whereas here in 4-stroke engine, every 4 revolutions there is 1 power stroke. Right. So, for example, say if the engine, let us take an example for 4-stroke engine. N equal to 1500 revolutions per minute, RPM. Let us consider N equal to 1500 revolutions per minute. Therefore, how many how many cycles are there? Right? Every 2 revolutions constitute 1 cycle. Right? So, there are 750 cycles per minute. If the engine runs at 1500 RPM, there are 750 cycles per minute. Right? 750 cycles. Every cycle constitutes 4 strokes, 2 revolutions. Okay? 4 strokes. In every 4 stroke, 1 power stroke. Therefore, 750 times there is the engine is firing takes place 750 times per minute, right? In case of 4-stroke engine, in case of 4-stroke engine, that is because the RPM here we have considered 1500 revolutions per minute. So every 2 revolutions there is 1 power stroke, right? Every 2 revolutions there is 1 power stroke. Therefore, 760 cycles per minute. Every 2 revolutions constitute 1 cycle. 750 cycles per minute. Every cycle there is 1 power stroke. Therefore, the engine fires 750 times per minute. Per second, 750 divided by 60. So this is how the firing takes place when the engine runs at 1500 RPM. When the RPM is increased, this will also increase. Right? So this is the fundamentals of turning moment and crank angle diagram. Therefore, the flywheel reduces the fluctuation of energy by observing The energy, when there is excess of energy and and gives out its energy, there is a requirement of energy. When the energy is more, the speed of flywheel increases. When the energy is less, the speed of the flywheel decreases. So this is the turning moment versus crank angle diagram.